Hello friends. Before we start learning about embedded C programming, let's quickly find out what is an embedded system. Embedded system can be best described as a system which has both the hardware and the software, and the system which is designed to do a specific task. Look around, we find ourselves to be surrounded by various types of embedded systems, be it a digital camera or mobile phone or the washing machine. All of them has some kind of processor functioning inside it. Associated with each processor is embedded software. If the hardware forms the body of embedded system, then the embedded processor acts as a brain, and the embedded software forms its soul. It is the embedded software which primarily governs the functionality of any embedded system. Embedded systems can not only be the standalone devices like a washing machine, but also be the part of much larger system. An example for this is a car. A modern day car has a several individual embedded systems that performs their specific task with aim of making smooth and safe journey. Some of embedded system in car are anti-braking system, temperature monitoring system, automatic climate control, tire pressure monitoring system, and engine oil monitoring system. Let's try to find out how we can program for embedded system. As mentioned earlier, embedded system consists of both hardware and software. If we consider simple embedded system, the main hardware module is the processor. The processor is the heart of embedded system, and it can be anything like microprocessor, microcontroller, DSP processor, CPLD or FPGA. All these devices have one thing in common: they are all programmable. That is, we can write a program to define how the hardware actually works. Embedded software or program allows hardware to monitor external events and control external devices. During this process, the program of embedded system may have to directly manipulate the internal structure of embedded hardware, such as serial communication interface, interrupt handling, and input output port. From this, it is clear that the software part of embedded system is equally important to the hardware part. There is no point in having advanced hardware component with poorly written program or software. Embedded system programming is different from developing application on desktop computers. The key characteristic of embedded system when compared to the PC or desktop are: embedded devices have resource constraint. That is, we have limited ROM, read-only memory, limited RAM, random access memory, limited stack space, and less processing power. Components used in embedded systems and PCs are different. Embedded system typically uses smaller and less power consuming components. Embedded systems are more tied to the hardware. Two silent features of embedded programming are code speed and code size. Code speed is governed by processing power and the timing constraints, whereas code size is governed by available program memory and the use of programming language. Goal of embedded system programming is to get maximum features in a minimum space and minimum time. Embedded systems are programmed using different types of languages. Machine code, low level language like assembly, high level language like C, C++, Java, etc. and the application level language like Visual Basic. Now we know that we can program embedded system using different programming language. Now the question is which programming language to use. There are some factors which are important for selection of programming language. The first factor is size. The memory that program occupies is very important as embedded processors like microcontrollers have very limited amount of ROM, that is nothing but read-only memory. The second factor is speed. The program must be very fast, that is, they must run as fast as possible. The hardware should not be slowed down due to the slow running software. Third one is portability. The same program can be compiled for different processors. Fourth one is ease of implementation. Fifth one is of maintenance. And the last one is reliability. So based on these factors, you can select particular programming language for development of embedded system software. Okay, now let's see how we can program embedded system using assembly language. This is how we write code in assembly language. There is one software called assembler who converts assembly written code into machine code. Assembly language maps mnemonics words with the binary machine codes that the processor used to code the instructions. Assembly language seems to be an obvious choice for programming embedded devices. However, use of assembly language is restricted to developing efficient code in terms of size and speed. Also, the assembly code lead to higher software development cost and the code portability is not there. Developing small codes are not much of problem, but the large programs become increasingly difficult to manage in assembly language. Finding good assembly language programmer has also become difficult nowadays. Hence, high-level languages are preferred for embedded system programming. Assemblies also use, but mainly to implement those portions of code where very high timing accuracy, code size efficiency, etc. are the primary requirements. As assembly language programs are specific to processor, assembly language didn't offer portability across systems. To overcome this disadvantage, we use high-level language such as embedded C. Before going into the details of embedded C programming language, we will first talk about C language programming. The C programming language developed by Dennis Ritchie in the late 60s and early 70s. C programming is the most popular and widely used programming language. The C programming language provides low-level memory access using uncomplicated compiler and deliver efficient mapping to the machine instructions. The C programming language becomes so popular that it is used in a wide range of applications ranging from embedded system to the supercomputer. Embedded C programming language, which is widely used in development of embedded system, is an extension of C programming language. The embedded C programming language uses the same syntax and semantic of the C programming language, like main function, declaration of data types, defining variables, loops, functions, statements, etc. The extension in embedded C from the standard C programming language includes input-output hardware addressing, fixed point arithmetic operations, and assessing the address spaces. Use of C in embedded system is driven by the following advantages. C is small and reasonably simpler to learn, understand, program, and debug. C compilers are available for almost all embedded devices in use today, and there is a large pool of experienced C programmers. Unlike assembly language, C has advantage of processor independence, and this is not specific to any particular microprocessor, a microcontroller, or any system. This makes it convenient for user to develop programs that can run on most of the systems. C combines functionality of assembly language and the features of high-level language. C is treated as a middle-level computer language or high-level assembly language. It is fairly efficient. It supports the access to input-output port and provides ease of management of large embedded projects. Compared to assembly language, C code written is more reliable, scalable, and more portability between different platforms. Moreover, programs developed in C are much easier to understand, maintain, and debug. Compared to other high-level language, C offers more flexibility because C is relatively small, structured language. It supports low-level bitwise data manipulations. Compared to other high-level language, C offers more flexibility because C is a relatively small, structured language and it supports low-level bitwise data manipulations. Object-oriented language such as C++ is not option for developing efficient program in resource-constrained environment like embedded devices. Virtual functions and exceptions handling of C++ are some specific features that are not efficient in terms of space and speed in embedded system. Sometimes C++ is used only with very few features. Java is another language used for embedded system programming. It primarily finds usage in high-end mobile phones as it offers portability across systems and is also useful for browsing applications. Java programs require Java Virtual Machine (JVM), which consumes a lot of resources. Hence, it is not used for smaller embedded devices.